so we will look at, there we go. We will look today at bearings. A couple of things that I want to share with you guys is, not that, is this one. Here we go. So looking at a few different things and a few sort of principles, we'll look at a couple of different books. We'll start off with the Ed Rollo one, go through a bit of the theory there, and then we will go through it. Please ask questions as we go along. If you have any questions, I'd love you to do that, and we'll progress through it. A lot of literacy. This is the tricky part of this is typically the worded questions where they're worded and you've got no diagrams at all associated with that, and that's where it gets a bit tricky. Angle of elevation, I think most of you will know, we measure angles of elevation and depression from the horizontal, so looking straight out. If it's an angle of elevation, you're looking up. If you're looking 30 degrees up, that would be 30 degrees there. If you're standing here and you're talking about an angle of depression, 30 degrees would be going down, you'd be looking that way. So I suppose one of the main things that some people like to have in that book is this is the horizontal, right? This would be the horizontal, and we call this angle of, if you're looking up at an angle of 30 degrees elevation, that would be that one. Elevate, you go up an elevator. If you're depressed, you normally look down. So if you're looking at an angle of depression of 30 degrees, that would be looking down, okay? One interesting thing, right, is that if you're standing here and you're looking at a person who's up there, let's just say you've got to look at 30 degrees up. So if you're looking 30 degrees up of elevation, what angle would they be looking at you? Back at. Well, if you think about it, the horizontal doesn't change, right? Like that's still going to be the horizontal for both people. They're perpendicular to each other while they're perfectly flat. So you could actually make a box around here. This 30 degrees, well, that must be then 60 degrees here. This would be a corresponding angle over here. That has to be 30 as well. So if you think about where that person is, if they're standing up here and you're there, they're looking down at an angle of 30 degrees of depression. I-O-N. So you'll notice that the angles are the same. So if you look up at someone at 30 degrees, they're going to have to look down from there at you at 30 degrees. So you're going to find that they're equal, except, elevation and depression, one will be elevation, one will be looking down. And that's why they're the same, because of that. And that's my proof. That's one dot point you need to understand in the study design, which is pretty much angle depression, elevation. Also here, it's saying if you look up at 35, the person's down in the lighthouse, they'll be looking at you at 35 degrees, which kind of makes a bit of sense. Another thing we need to understand is the 3-digit bearing. So we need to understand a true bearing or 3-digit bearing, and we also need to understand the compass bearing too. So in terms of bearings, we break them up. We measure everything from north. Okay, never eat soggy Weet-Bix. Everyone has a different one. So if you're looking north, another way we can talk about that is 0, 0, 0 degrees true. Now, sometimes it's a true bearing, sometimes it's just a bearing because it doesn't always need to be true. It could just be on a bearing from wherever you're standing at, which is different. East, if you think about it, would be the next place you go to, and the bearing of that is 90 degrees. So you turn around 90 degrees. Now notice I write it with 3 numbers. We write it with 3 numbers so we are clear about which direction we're to go. Because when they're sailing, they don't just go, oh, head on 20, 20, because it might be like, was that 120 or 20? Because you don't want to go 20 degrees versus 120. There's a massive difference. So they say head on bearing of 0, 20, or head on a bearing of 1, 20, which would be down here. So south would naturally then give you a bearing of 180 degrees. So that would be 180 degrees true, 180 degrees true. Now, if we're talking about bearings, then they're true. And west would be 270 degrees true. So you can see that the range of bearings between here would be between 270 and 360 degrees. We can also call this 360, by the way, but normally we just call it 0. Here, your bearings are going to be between 180 and 270. If you're going in this quadrant, you're going to obviously have between 90 and 180. And in this quadrant, you're obviously going to have between 0 and 90. 090, that should be. There we go. Okay, and that's pretty much it, where we're going. So, for example, if you headed on a bearing of 20 degrees, 020, that would be here. Now, another thing we can measure with these is we can say that's 20 degrees here. Right, if that's 20 degrees, what bearing is that? If that's 20, that is. that would be a bearing of 0 to 0. Now we can also have a compass bearing, okay? So compass bearings, you can use north, you can use east, you can use south, you can use west, you can just use those, which you know. But what about if you said 0 to 0, what would that be? Well, we measure it either from the north or the south. So that would be, well, north. So 0 to 0 degrees true is the same thing as going, well, start at the north and move 20 degrees to your east. If I had a degree of, say, 0.70, which is down here, well, you start at your north and move 70 degrees to your east. Let's say I had 120, which is in here, 120, all the way around here. If this is 120, what would that be? Well, 120 degrees, true, would be the same thing as, now we only measure from south or north. Now, if you're down in this quadrant, you're going to measure from the south because it's a lot closer. So south, you measure from west to east. North, you measure from in these two quadrants. If it's just east, you just write east. If it's just west, you just write west. If it's just north, you just write north. So how far is this from the south? Well, it's 120 degrees from here. But you got to remember, this inner angle here would be 30 degrees because it's 90. Right, plus 30 would make 120. So from the south, we're actually 60 degrees. So that's going to be south, 60 degrees to the east. So for example, if I had an angle of 200, that's over here, that would be south, 20 degrees to the west. If I had an angle, let's say 310. So you're up in this quadrant. We're going to measure that from the north, 310. Well, degrees true. Well, if you think about 310, it's measured around here. So 310 would be about 40 degrees off here, right? 270. We want to measure it from the north. So that's actually going to be 50 degrees because it's 50 degrees off 360. So you got to come back. So that's going to be north, and you go 50 degrees to your west. And these are what we call our compass bearings here. So we can get there with those. So sorry, that's a 3-digit compass bearing, the other one, or a true bearing we can call it, which is fine. And we can have the other ones as well. So, yep.
If you go back to the notes.
Notes, yep, these ones.
For the second one.
Did I do something wrong? Yep, this one.
Yep. Why don't we include the E?
Oh, it should be the E. Good point. Yep, definitely should be E. So north 7 degrees to the east, because if it's north 7 degrees to the west would be like 290. So that's completely different. So you should always have one of these. You can also, you know, if you had 090 degrees, for example, that's just east. If you also have, if you got like 180 degrees true, that's just south. So that's how we can convert between these, which you should know. I think it's a really good bit of information because you can always sometimes have these bearings. Good question. So what we look at is, that's our bearings. Now, the difficulty with these bearings is if you're talking about, right, and there's the word from and to, right? From is really where you're standing, right? To is where you're looking or going to, or traveling towards. Now, these are really important words because they come up all the time in bearings. So if I say I'm traveling, so for example, if we look at this example here, the bearing from point X. So we're going from point X to point Y is 65. So from point X to point I is 65 degrees. So we're standing here and it's 65. 00065. So this isn't necessarily a true bearing. It just depends where you're originally standing. They put north here, so let's assume it is. So it's 65 degrees going that way. The bearing from point Y, so if you're standing from point Y to point X, is 245. Now, there's 180 degrees difference in this. If you think about it, if you walked along this line, you stopped and you wanted to go back, you would turn around 180 degrees, right, and walk back straight along the same line, and it would get you there. So really, I like to think of turn around. So really what you need to know, and that's another one, is that compass bearings differ by 180 when reading from each endpoint in a particular line. So if that's 65, that's going to be plus 180, which is going to be 245. Now, obviously, if it's over 180, you minus 180 from it, and that will give you 65. So they'll tell you where they are, because if you think about it, you're going to have to turn around 180 degrees. If you're walking this way on a bearing of 245 degrees and you want to go back, you'd turn around 180 and then walk backwards. So that's another point to really realize that the bearings from point to point, if you're looking at them, are 180 degrees difference. Again, 65 degrees here, that's going to be 65 degrees there, right? That's another way you can explain it, which is, let me just draw that down so you guys can see it. So really, another way you can explain it is if I've got 65 degrees in here, if this is 65 degrees, they're corresponding angles, right? This is 65 degrees. So what's this angle? Well, this angle is going to be 180 plus that. So that's another way you can look at it because of the corresponding angles. So they're always 180 degrees difference looking at each other. All right. Then it gets into the tricky stuff where really it's drawing a diagram from word and information. You've got that, and you've also got 3D ones as well. And that's pretty much it. It's to and from, and we're going to look at some of those. So I'm just going to go through the other text now. So we've already looked at sight, angle of elevation is from the horizontal, angle of depression is from there. You can see that both of these angles are the same. This is on Compass Resources as well. If you want to have a look through it, it is on Compass Resources. It's chapter 13 under measurement and geometry. Find the angle of elevation, correct the 2 decimal places of tower measured from the road. So if this is the angle, right, you want to find the angle of elevation. We're talking about this angle. Well, if that's 150 meters long and it's 20 meters high, your opposite and adjacent, it's going to be tan. So it's going to be the inverse of tan, 20 over 50, over 150, and you'll get your answer in degrees. And we want to give that to 2 decimal places. For example, find the altitude of a plane correct to the nearest meter if a plane is sighted 4.5 kilometers directly away from an observer. 4.5. Who measures an angle of elevation of 226.38. Find the altitude. Now, altitude means how high it is off the ground. Now, assuming you're on flat ground, we know the angle. We have the hypotenuse, and we want to know the opposite. You're going to use sine. Put in all the information. The angle of depression from the top of a 35-meter cliff to a house at the bottom is 23 degrees. So we've got the top of the cliff and a house, if you look down, angle of depression is 23. So you've always got to draw a diagram, and that's the hardest part about it. How far from the base of the cliff, this is the base of the cliff, is the house? That's this distance, right? So the angle of depression from the top of a 35-meter cliff. So the cliff is 35 meters, and that's a tricky one, from the top of a 35 meters. Right, so you can think that to a house, so the depression is 23. So you've got to find all the hidden information. You need 2 bits of information normally with these, elevation, depression, and you can find it. Just remember, how far is the house from the base of the cliff? This is the base of the cliff. If I said how far is the house to the top of the cliff, it would be this line. So now you've got this triangle here, and you want to find that distance there. Well, that's 23. You could figure out the other angle in here, which is going to be 77. No, that's not right. Sorry, 67, I should say, because I shut up to 90. Or you can use this angle in here, which is going to be 23. So you can go 23, find out X, and you got 35 here, because these are corresponding angles, right? So you could use opposite, which is what and you want to know adjacent. So that's going to be TOA, tan. Or you could give this as 67 degrees, right? And if that's 67 degrees, then your this would be your adjacent, and then that would be opposite. So either way, you'd get to your answer. So that's angles of elevation and depression, which really aren't, I think, too bad. So with those, let's just try one of these ones. Question, I didn't want to look at question 18. Let's look at question 18 because that one is a pretty good one. So question 18 is a boy standing 1.5 meters tall. The angle of elevation to the top of the goalpost using an inclinometer. An inclinometer is a thing that you use to measure the distance. If the angle was 15 degrees when measured 50 meters from the base of a goalpost, how tall is the goalpost? So it's 50 meters, right? So he is standing here, right? And this is where you got to always draw your diagrams, right? He's looking at an angle of 15. And the base of the goalpost to where he's standing is 50 meters. And this is the goalpost, right? So he's standing here, and he is 1.5 meters tall, we're assuming. So if you think about it, if you're doing 15 degrees, that's from where you look though, right? So this angle, and this is 50 meters here because this is 50 meters. Don't forget to add your 1.5. This is only going to give you your length from here to here. So what we're going to need to do is we've got our adjacent, and I want to know my opposite. So it's going to be tan, 15 degrees. Now you could just do this in your CAS, just draw the triangle, but it is a right angle triangle, equals opposite TOA over adjacent, 50. So this is 50, tan, 15. So 50, tan, 15, pull up your CAS. 50, tan, 15. Make sure we're in real deg. We're in deg, real deg. Keep deg real. Deg's a good buddy. It's 13.4 meters plus the 1.5 meters because that's only from the horizontal. So then it's going to be 14.9 meters. Does that sound right? It's a pretty tall goalpost, but yeah, it sounds right. I mean, it's not like 50 meters, right? So I'm pretty happy with that one there. The angle of elevation to the top of the goalpost is now 55. How far away is the boy from the base of the goal? If it's now 55, the angle of elevation, that means he's obviously walked in, right? So if you think about it, well, if it's 55, he's looking right up now, right? Now we know that the goalpost the total length was 14.9, but he hasn't shrunk. He's just walked in. So we've got to treat this as 13.4 or whatever it was. And now we want to know what this angle is, right? So we want to know what that is. We want to know how far. No, we know this is 55, sorry. So we want to know how far he is from the goalpost now. So now we know our opposite. We want to know our adjacent. So we've got the angle here. So that's going to be, we should just do it. We should write this down. TOA tan 55. TOA equals 13.4 on X. So X will equal 13.4 on tan 55, or you can just put that in your CAS. So it's going to be this one. Now, it didn't say using my answer, did it? Did it say using my answer? No. So I'm just going to use this one. You probably would normally be told to use your answer. And that's going to be divided by tan 55. I'm in real degrees. Yes, I am. So he's now 9.4 meters away. Now, does it sound right? Yes, it does. Like if you're looking up at 55 degrees, that's a pretty steep look. So 9 meters, he's came in shorter. Yeah, that makes sense. So I'm going to leave that question there. That's how we can use elevation and depression. Fine, they're not too bad. Here, we've got compass bearings and we've got true bearings, which we kind of went through. Again, hopefully that makes sense. Northeast is 45, southeast is 135, south and so on. Again, if you've got 22.5 degrees, this is which is northeast. You don't really need to know these, but obviously that's northeast. Northeast would be here. Northeast would be here, and so on. We don't really use those though. You need to know these ones. North, 40 degrees to the east. That would be the same thing as 020. This is south, 58 degrees to the west, which would be the same thing as 180 plus 58. So you need to know how to convert between these. And find those, which I think is pretty easy. Most people normally get the hang of them. Go away. Okay, so let's move on. Some examples. Navigation. and specifications and specifying where the points are. A ship leaves port heading 30 degrees true for 6 kilometers. How far north or south is the ship from a starting point? So if you were only given that, and I'm not going to do the maths, but I'm just going to do the drawing. So if you're only told that a ship leaves north on 30 degrees true for 6 kilometers, so you always draw a little compass bearing from where you're leaving and wherever it goes to. Now it's gone on a bearing of 30 degrees. Roughly get your bearings right. So it's 30 degrees true. So that means it's gone on an angle here, 30 degrees. And then it gets to here, and we know this is 6 km. And we said, how far north or south of is it from its original point? Well, how far north would be this line here, right? So what you can do is you can create a right angle triangle. You now have, this is 6. You can now pull out your triangle. I always try to. We know that this is 30 degrees. We know that this is 6, and we want to know what x is. So this is our hypotenuse, and I want to know my adjacent. I'm going to use cos. Solve that. You'll find out how far north it is. How far east or west is the ship? Okay, we want to know. This is how far east or west it is, right? East. And I'm expecting how far east. So I would say, once I know this, I'd say it's that many kilometers north. East would be this one. So I've got this, my hypotenuse, and I want to know my opposite. That would be sine. Solve that, and that's how far east you are. And as I say, just draw a diagram. So I just wanted to use this one because you can watch the Ed Rollo videos to do that. So let's do this one. A triangular paddock has 2 complete fences. From location D, one's fence line is on a bearing of 337 for 400 meters. The other fence line is that for 700. So if I didn't have a diagram, again, I would just pull out your pen. Here's point D. Now notice we've got to read the words. A triangular paddock has 2 complete fences from location D, where we're standing from. One fence lying is on a bearing of 337. So I'm going to draw a little bearing here. Think about which quadrant is 337 in. Well, remember at the start, this is between 270 and 360. So 337 would be, if that was 270, 337 would be 60 odd degrees. So it's going to go up pretty sharp, like that. And I know that this angle in here is going to be what? Right? That's 337, I think they said. 337, so this is 337. So the angle in here is going to be 337 minus 270. So that's going to be 67. And that goes for 400 meters. Then they've got another one, which is 235 for 7 meters. 235 would be down here. That's 235 from 370 would be only 35 degrees off, right? So that goes for 700 meters, I think they said. Yep, 700. Now, that is 235. So if you think about it, the angle on here would be from 270 to 235 would be 35. So this total internal angle now, I can figure that out, is going to be 102. Now, I would use a CAS as an exam, by the way. I'm just doing this in my head. So now I've drawn a diagram, and it says, find the length of fence to the nearest meter to complete the enclosure triangle. So we want to go, from here, this is 700 meters, by the way, so that probably would have gone a bit further. From here to there, it's going to be a straight fence. So what is it? Well, if you think about it, now I've got a triangle like this. Now I'm going to pull out all my information. I want to know what this is. I've got 400 here. I've got 700 here. And this is where you'd use the geometry function in your CAS, and that's 102. Now I'll just whack this in my CAS, like do the feature. Now if it said show using, you'd have to use the cosine rule here, right? Like I wouldn't use the cosine rule. This is where a lot of students struggle. Just go straight to your CAS and use that geometry feature that we're showing. So half the trick is drawing it. And that's that one.
So for that question,
Yep.
If it says use cosine rule, we have to use cosine rule, and we can't do it on CAD.
Yeah.
Like geometry.
Spot on. Yeah, if it said show using it, yeah.
Okay.
Soldiers on a reconnaissance set off on a return journey from their base camp. The soldiers consist of 3 legs. The first leg is on a bearing of 150 degrees for 3 kilometers. So let's do this one. So maybe you guys can have a go at reading this one. Try and draw that one out. Why don't you try and draw that one out, and we'll see how you go. So hopefully you're getting there. I'm just going to fix up this screen. Bear with me. Do that. So soldiers are a reconnaissance and they set off on a journey from their base camp. So let's just go with B is here, base camp. Always draw a compass bearing at every point, guys. That is the trick. And the journey consists, the first leg is, and they're doing a return trip. The first leg of the bearing is 150 true. 150 true would be down here. If you think about 150 true from 90, that would be 40 degrees. So we know that this is 40. We also know that that has to be 50 in here, right? So we've got those 2 bearings. And we know that that is the first leg for 3 Ks. The second is on a bearing of 220 degrees true. So we've got to stop. So yeah.
It wouldn't it be 60? Or 40?
Did I stuff that up? What are we doing? 150, 150 plus it 90. Would be 60. 90. Thank you. Yes, it would be 60. Thank you very much. Nearly made a big mistake there. Use my eraser. Hopefully you guys have got one. You will need it. Oh, doesn't even let me do it. Thank you. It would be 60. Let's do that again. Starting on a bearing, 60 degrees. That means this would be 60, right? This would be 30. This is B. And we go for 3 Ks. Then when we get there, you want to draw another bearing. Then they head off on 220. 220, let me think about this, would be 40, would be here. For how long? For 5 Ks. And that means this internal angle here to this one would be 50, right? You also know what this angle is, because this is a corresponding angle, because these are parallel with each other. So this has to be 60. And that's 30. So you know this total internal angle now is 110, and that's the trick here. And you head off on 5 Ks. Then it says find the distance, the direction and distance correct to the 2 decimal places of the third leg by which they return to base camp. So we're saying, hey, from here, what direction do I need to go in? Now, because I've drawn it here, doesn't necessarily mean it's going to be on this bearing. It could be here, right? Like, and you might have to go on a bearing like that. So sometimes you've got to recognize that your diagram may not be accurately correct unless you bring a protractor in and you do it to scale. Like you went 3 centimeters, 5 centimeters, then you could actually literally measure it too. So what I've got to be wary is, I know I've gone sort of south. I could expect my answer to be in any of these 2 quadrants. So don't get thrown off by that. Now I'm going to draw that, and that's where a lot of people sort of go quite wrong. I'm going to just draw this. And then I'm going to go, okay, what information do I now have? So hopefully you got to that point. What information do we have? And I'll pull that is. Let me just redraw this because it's getting quite mucky. It's a really good technical word there, mucky. Geez, I haven't used that one in ages. Until I've got a young daughter. I know this is 110 degrees. Let's just pull out all the information. This is 3. This is 5. And I actually know what this is. No, I don't know what this is. Because don't forget, this isn't 30. That's 30 degrees to the south. So I don't have any other information. But I've got all my information now. Now what I want to know is I want to know what angle this is. I know that this angle down here is going to be 50 degrees, right? This is going to be 50. So what we're going to do is we're going to get onto our CAS and we're going to find out what that is. So I'm going to go into, you could either use cosine, but personally, I'm pretty lazy when it comes to these things. I'm going to go edit, clear all, hit OK. I'm going to draw a triangle. I'm going to put all the information I know. So I'm going to treat that as 3. Lock it in. I'm going to treat this angle as a 110. Lock it in. And I'm going to treat this length as 5. Lock it in. And then I'm going to zoom out. Okay, so that's it. So the length would be 6.6, and the angle that this makes in here is 25 degrees, right? So we know that this is 25 degrees, I think I've got. So that's 25 degrees. Now don't forget, that's 25 degrees in here. Don't forget, we know that this is 50 degrees from east. So what bearing do I need to take? I need to go back 50 and 25. So that's back 75 from 90, which is going to be 15 degrees. So the bearing you're going to take is 0.15. And the length I'm going to do, and how long do I need to walk for that? I think it was 2 decimal places. Is 6.65 kilometers. So that's sort of where we're trying to go with there. So that's how we should get that. Let's hope we got it right. So the trick was finding out that that angle there was 110. 15 degrees, yep. And the distance is 6.65. So that's how I go about it. Now, that's why when you're drawing these, you've always got to look for your corresponding angle and understand that, you know, you're doing a triangle. That doesn't mean that's the actual bearing you're heading back on. You've then got to relate, once you've found out this, back into here. So that's 25 degrees. Well, what angle is that? We don't know. So you've got to then find out. You've got to base it off your compass orientation bearing. And that's about as tricky as they get, guys. Things like that. They do get a little bit more tricky, like to and from and words like that, which we will work through a few more. But as a general introduction, that one's a really good one, I believe. You know, that will really help you to get there. The main trick is when you're dealing with things, you want to draw compass bearings on every single one. You really just want to draw compass bearings on each single point, and that will help you a lot. So I'm going to leave it there, and I hope that helped you a lot. But it does get tricky, these.